Hello, my name is Miroslav Pencev. I'm a researcher at the University of California, Riverside, located in Southern California in the United States. I will present the analysis conducted by our research team on energy costs and infrastructure requirements necessary to support future medium and heavy-duty zero-emissions vehicles. The South Coast Air Quality Management District, located in Southern California, includes Orange County, parts of Los Angeles County, most of Riverside County, and a small part of San Bernardino County. It is one of the most polluted areas in the United States. Transportation is the main source of air pollution, with commercial, medium, and heavy-duty trucks being major contributors to air pollution from transportation. Their number in the region is significant because the ports of Los Angeles and Long Beach are a major transportation hub for international goods trade with the United States. The goods transported by sea on container shipping ocean liners are transported on land through the South Coast Air District. The transition from conventional fossil fuel-powered medium and heavy-duty vehicles to zero-emission vehicles like battery electric and hydrogen fuel cell vehicles is driven by a few policies in California, like the Advanced Clean Trucks Rule and the Advanced Clean Fleets Rule. The aim of our research is to identify the necessary infrastructure requirements to support future medium and heavy-duty zero-emissions vehicles in the region. These include quantifying vehicle miles traveled by future ZEVs, renewable energy, both electric and hydrogen fuel, and number of charging and fueling stations to support future zero-emission vehicles. In addition, we perform geographical analysis to identify locations in the region for future stations based on traffic demand and resources available. Our analysis presents estimates for total daily vehicle miles traveled by battery electric and hydrogen fuel cell trucks for the years 2025, 2030, and 2040. While projected numbers are quite low in the year 2025, less than 13,000 for battery electric trucks and approximately 5,000 for hydrogen fuel cell trucks, these numbers increase to 2.7 million and 519,000 respectively for the year 2030, while in the year 2040, vehicle miles traveled for battery electric trucks are 6.4 million and vehicle miles traveled for hydrogen fuel cell trucks are 1.7 million. Total daily energy requirements in terms of electric energy and hydrogen fuel are calculated based on energy efficiency of these zero-emission vehicles. For example, in the year 2040, more than 8 gigawatt hours of electric energy is needed and 160 metric tons of hydrogen are needed to power zero-emission vehicles. Estimates of reduced tailpipe emissions in 2025, 2030, and 2040 due to deployment of zero-emission vehicles are presented. They include greenhouse gas emissions, particulate matter, PM2.5 and PM10, oxides of nitrogen or NOx emissions, as well as carbon monoxide and oxides of sulfur. While reductions of medium and heavy-duty vehicle tailpipe emissions in 2025 are quite small, they increase to about 10% in 2030, and in the year 2040, the reductions in tailpipe emissions are between 15 and 20%. A heat map showing location preference for future electric charging and hydrogen fueling stations in the South Coast region is generated using geospatial analysis. This analysis takes into consideration medium and heavy-duty vehicle traffic volumes, proximity to highway on-off ramps, proximity to electric substations, proximity to electric transmission lines, land use designation, and others. Several hotspots on the heat map are shown at Long Beach, Los Angeles, and Ontario. With that, I'd like to thank you for your time.